The universe is constantly screaming at us. But for the most part, we're completely deaf. Every single second, this incredible flood of cosmic information washes over the Earth. But our own eyes, they can only pick up the tiniest sliver of the story. So, how did we build new senses to see all that invisible stuff? Well, that's exactly what we're going to dive into.
Okay, so check this out. You're looking at the exact same galaxy, but in 3 totally different ways. In visible light, it's that gorgeous swirl of stars we all know and love. But switch over to radio waves, and suddenly it's this ghostly, almost ethereal cloud. And then you look in X-rays, and it becomes this collection of violent, fiery hotspots. So what's the deal? How can one single object be all of these things at once? The answer to that question is really the key to everything.
It all starts with a huge problem right here at home. See, we're trying to look out at the universe, but we're doing it through a blurry protective blanket, our own atmosphere.
Yeah, think of our atmosphere as a super strict bouncer at a cosmic nightclub. It lets in a tiny little bit of visible light, the stuff our eyes evolved to see, and a slightly bigger chunk of radio waves. But all the really wild, energetic stuff, the gamma rays, the X-rays, most of the UV and infrared light, nope, they are turned away at the door. To them, our sky is basically a brick wall.
But we're not completely blind. Luckily for us, that atmospheric blanket has 2 main holes in it, 2 windows that let us peek outside from right here on the ground.
So here's the crucial part. These 2 windows give us completely different views. On one hand, you have the optical window. That's what we see with our eyes, what traditional telescopes see. It's awesome for looking at starlight and figuring out how hot stars are. The big problem, though? Interstellar dust. It's like cosmic smoke that can totally block our view. But then you've got the radio window. It slices right through all that dust, letting us map out the hidden structure of our own galaxy, and even find these cold, dark nurseries where new stars are being born. The catch? The images are unbelievably blurry.
So we have this amazing radio window that lets us see through all the cosmic muck. But it comes with that one giant catch. Because the wavelengths of radio light are so long, we get these incredibly fuzzy pictures. To get a sharp image, you would need a single radio telescope of an absolutely impossible size. And when I say impossible, I mean it. To get a radio picture that's as sharp as a normal optical one, you'd need a single dish that is 13 kilometers wide. I mean, seriously, how on earth do you even begin to build something like that?
Well, here's the brilliant part. You don't. You fake it. The solution is this incredible technique called interferometry. Basically, you link up a whole bunch of smaller telescopes and combine their signals with perfect, down to the nanosecond timing. When you do that, you digitally create a single, giant, virtual telescope. It's just like how your 2 eyes give you depth perception. With telescopes, the farther apart they are, the sharper their combined division becomes.
So here's how that magic trick works. A single radio telescope by itself has really poor angular resolution. That's just the fancy term for its ability to see fine details. It's like having really blurry vision. But by electronically linking a whole bunch of these telescopes, sometimes hundreds or even thousands of kilometers apart, we create a virtual dish that's as big as the distance between them. And the result is just wow. A fuzzy, indistinct blob transforms into a sharp, incredibly detailed image. So just how big can we make these virtual telescopes? Well, get this. The Very Long Baseline Array links telescopes all the way from Hawaii to the Virgin Islands. That creates a virtual telescope that is 8,600 kilometers wide. It's nearly the size of the Earth itself. And to give you an idea of just how sharp that is, it's like being able to see a baseball sitting on the surface of the moon. It is just an incredible feat of engineering.
But even with all this amazing ground-based tech, remember that first slide? The one showing all that light our atmosphere blocks? We're still missing most of the story. To see the rest of the picture, we have to do the most extreme thing imaginable. We have to leave our planet entirely and go to space.
The biggest reason we go to space isn't just to get a clearer view. It's to see at all. We have to go to space to access that whole high-energy universe of UV light, X-rays, and gamma rays that our atmosphere completely shuts out. It is the only way to get the full picture of what's happening out there in the cosmos.
And Hubble is the perfect example of this. Its main mirror is only 2.4 meters wide, which is actually pretty small by today's standards for ground telescopes. But because it's floating above the blurry atmosphere, it can produce images that are sharper and see objects that are fainter than any telescope on the ground. It's not about being bigger, it's about being in a much, much better location.
All right, so going to space seems like the ultimate solution, right? A perfect, pristine view of the universe. Well, the reality of observing from orbit is actually filled with some pretty surprising challenges and a lot of misconceptions. So let's bust a few of those myths.
Okay, myth number 1. Space telescopes can just stare at an object 24/7.
You'd think so, right? But the reality is, for a telescope in low Earth orbit, our own planet is a giant obstacle. Every 90 minutes, it makes a full trip around the world, and for about 45 of those minutes, the Earth itself is blocking the view. It's basically a constant cosmic game of peekaboo.
Myth number 2. The sky from orbit has to be perfectly pitch black.
This one is really surprising. The truth is, the sky in orbit is only about half as dark as the darkest places you can find on Earth. Even out there, in the void, you're surrounded by this faint, cosmic glow. It's sunlight scattering off all the dust between the planets, and the combined light of billions of galaxies that are just too far away to see as individual points. So no, we are never truly in the dark.
And the final myth for today, space has no weather, so it's smooth sailing for observations.
Oh, if only that were true. In reality, space is a brutal environment. These telescopes are constantly being bombarded by cosmic radiation, they get fried and then frozen by these extreme temperature swings, and they're totally at the mercy of violent storms from our own sun that can just cripple their electronics. It is a constant battle for survival out there.
But the biggest, most sobering reality check of all is the price tag. I mean, just look at this chart. The cost difference is absolutely staggering. A space telescope can easily cost anywhere from 100 to 1,000 times more than a similar instrument built on the ground. It is an astronomical investment, in every sense of the word.
So from building virtual telescopes the size of planets to launching observatories beyond our own atmosphere, we have just relentlessly pushed the boundaries of what we can see. We built ourselves new eyes to see the invisible, and in doing so, revealed a universe that is so much more complex and beautiful than we ever could have imagined. But every new thing we see just reminds us how much more is still out there. And that leaves us with the most thrilling question of all. What incredible wonders are still hiding, just beyond our sight?